Hello everyone, and welcome to the new Intro to Scripting in Unity series, where we'll be creating a simple but fun 3D platforming game that lets an animated character move around and jump both off the ground and walls. This series will be aimed at people new to programming. As such, we'll be covering a bit of programming basics before we actually get our character up and jumping. In this video, we'll be covering some programming basics and getting a character that we can actually move around a bit. So, starting off, create a new Unity project. You do this by either going File, New, or if you're just starting Unity for the first time, it would come up with a different screen where you click on New, and then this would pop up, and then you can just name your project, whatever, simple third-person platformer. Alright, and make sure your presets are set to 3D. Just click on it to make sure, and then hit Create Project. And then after a short loading time, you will get a screen that looks like this, except for it might be lighter if you're using normal Unity rather than Unity Pro. To start off, I'm going to click and drag this hierarchy thing here and move it to this side of the screen. And that's just because I find it a bit more efficient to have the inspector right next to the hierarchy. But getting into the coding, let's see here. We'll right-click on Assets and go Create Folder. And we're just going to create a folder that we will put all of our scripts in. So we'll do _scripts. The underscore is just to make it so that it comes earlier in the alphabet, so if you have other folders in there, your scripts will be right at the top. Double click on the scripts folder and hit create C# script. And name it just basic testing, or just my first script. I think that's more appropriate. My first script. Alright, when you installed Unity, it should have come with Visual Studio 2015 or Visual Studio Developer Network, something like that. And when you double click on the script, it should automatically start up Visual Studio. Perfect. Alright, so when you first open it, it'll look like this. This probably looks a bit scary. There's a lot of stuff going on that's just filled in here. But you don't really need to worry about any of this right now. All you need to worry about is putting stuff in here. Right where it says Start. Stuff that you have in here will be executed as soon as you start the game. Also note that scripts, when you write them, they are attached to objects like any other thing. So if you go like create a plane in Unity and you put like a rigid body on it, so rigid body, you would attach a script in the same way that you do that. And likewise, you can also set properties on your scripts the same way that you can do it with the built-in components. So let's go ahead and remove that. Hop over back to Visual Studio. And first thing to note is that C#, which is the language we're using, is not white space dependent. So I can hit enter here, I can throw in a bunch of spaces right here, and it's not going to make any difference to the program. Like I can just have a bunch of blank stuff here and it won't do anything different. So you can use the white space to just format it to make things easier to read. There are a couple of conventions that people follow just to make things easier to understand. But should you want to, you can just arrange things however you want, as long as you don't like split a word in half like this. Then bad things happen. But so inside the braces here, next to the start, we're going to start off with what's called a method call. So in C#, when you see these parentheses, that means that whatever is preceding it is a method. And a method is just something that executes code. So when our game object is created, this start method is called automatically. So whatever is inside of here will be invoked or executed, whatever code you write, automatically by Unity. So whatever we write here, so we'll start off with, if my keyboard is in Dvorak mode, can start with print. Now before completely typing it out, you can look at Intellisense here, which is this pop-up that comes up, and you can see logs message to the Unity console. So this will basically take in whatever we put into it, and it will just print it out to the screen for us. So if we create an opening parenthesis, again, parentheses basically mean you're doing something. It's calling a method which is basically do something with stuff. and whatever we put in, it will print out to the screen. So we're going to pass in what's called a string, which is just like a word. And the way you pass in a string is by using double quotes. So just two quotes, and then in between them you can put whatever you want. In this case, we'll just type out "Hello World!" exclamation point. Now that by itself should be enough, but you'll notice there's a small red underline right here. And if you mouse over it, it says semicolon expected. In C#, semicolons basically tell the program that, alright, what we want here is done. That's just it for that particular section of program. Every single time you write a line, you end it with a semicolon. It's called a terminator. It just basically says, alright, this statement is done. If I want to, I can go on and write another statement, or we can just end it right here. So go ahead and hit save, and let's hop back over into Unity. And hit play. And you'll notice nothing really happens. If we open up the console here by clicking on this tab, nothing happens. So why is that? If you recall, I said that they were attached in the same way that like rigid bodies were attached to any component. So if we go over to the project view again, we can click and drag our first script onto the plane here. It doesn't really matter what it is. You'll notice that there's no like properties that we can set on here. It's just there. But if we hit play, you'll notice in the console it now says "Hello World." Now, what if we wanted properties that we can set and stuff? Like maybe we don't want it to say "Hello World" every time. Maybe we want it to say something that we want to specify in the editor here. So we can just click here and like type it out and have it say what we want. So in C#, you're going to have a couple of different what are referred to as types. Also, note these green words. These are comments. They do not affect the execution of the code in any way. So you can type whatever you want here and it won't do anything. So, a string. This is just words surrounded by quotes. You'll also have an int, which is an integer, like -1, 0, 1, etc. You have float, which is like 2.345, just decimal numbers. And you have a bool, which is true or false. These are the types that you'll probably be using the most often. Just bool, string, int, and float. Now, the way you create a variable is by simply writing the type first. So it can be string, int, float, bool. In this case, we want a string because that's a bunch of words. So string, and you do it outside of the start method, and then we give it a name, like what we want to call the string. Not what the string contains, what we want to call the string. And in this case, we could do what to print, and that's the name that we give it. And we end it with the semicolon. Also, before the string, we need to make it so that the Unity editor will actually show it in the inspector. So we need to make sure that it will actually appear over here. And the way we do that in Unity is by simply putting public before this. It does other things as well, but the main thing that it does is make it so that Unity will show it in the inspector. And then, instead of "Hello World" right here, let's just print out what to print. So whatever this variable, what to print, contains, it will print out to the screen. If we save this and hop back over to Unity, wait for it to compile, you'll see we now have what to print and then just a blank rectangle next to it. And we can type whatever we want in here and then hit play. And you'll notice it gets printed out at the bottom of the screen. That's all fine and dandy, but just printing out a word that we type in isn't really fun at all. Like, there's nothing that it's doing. So let's hop back over into the script. And let's say we want to add a number to it. So you'll note that we have two real number types that we can use, int and float. Let's create an integer, so just 0, 1, 2, 3, 4. So public, so that it's visible in the Unity inspector. And then an int, which is the type that we want, and then give a name to it. We'll just call it my irrelevant integer name. And further, while this would work by itself, you can see if we hop back over into Unity and let it compile, we now have my irrelevant integer, and we can set the number here to like 10. Hold on, let's hit reset there. Can hop back over into Visual Studio, and after my irrelevant integer name, you can put a number. And this number is the starting value that will appear in the inspector. So if we hit save, and hop back into Unity, and reset the script, you'll notice that the value is 10. So this reset basically means you delete the component, then add it again. So if I were to remove the component and then hit add component, my first script, you see the default value is 10, and then we can have blah 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 as our what to print thing again. Now, if we hit play, it still just prints out our random gibberish. The number has nothing to do with it. But if we go back into Visual Studio, we can put plus my irrelevant integer name. Also, you can scroll in this list here, Intellisense, using the up and down arrow keys, and then hit enter, and that will automatically fill it in for you. Further, if you have a really long name, like my irrelevant integer name, you can, each of the capital letters that you have in the variable name, you can actually just type out. So this would be my irrelevant integer name, and it will automatically select it for you. So we can hit enter, and what this is going to do is it's going to take this string, this word here, and add the number to the end of it. So what ends up happening, we hop back into Unity and hit play, apparently I missed, is we have our gibberish and then plus the number at the end. But you'll also notice that there isn't a space between them, like it looks like the number has just been tacked onto the end of it. So we'll do my number and it's just tacked right onto the end of it. Even if you can't see something like a space, it's still there if it's in a string variable. So if we attach a space to the end of my number colon, and then we look in the console again, you'll see there's actually a space in between the colon and 10 now. Alternatively, you can actually hard code these things by adding in another thing here. We'll put in another plus, and then just have quotes with the space in between there. And now if we save it and hop back into Unity, and we make sure that there isn't a space at the end there, we'll see that there is still a space when it's printed out here, and that's because we're manually adding in the space to what we print out right here. Alright, so let me just tidy this up a little bit. Also, we don't need this update method, so I'm going to delete that. Now, you'll notice our variable what to print, it's not really named correctly anymore because what is printed isn't what to print, it's what to print plus a space plus my irrelevant integer name. So, one thing that Visual Studio lets us do, if you hold Control and press R and then press R again while still holding Control, you can actually rename a variable. You have to make sure that your cursor is on the variable name first though. And we'll put this, we'll rename it to just my string. Now it's no longer incorrectly named. Even though it had an inaccurate name before, it wasn't affecting the execution of the program. It was just making things a bit confusing if we were looking at the script, because it said what to print, but what was being printed wasn't actually what to print. If we go into the method here, we can actually create another string variable, and we'll call this toPrint. And we'll start it off with just nothing in there. Now, what the equal sign means in C# is basically take the value that's on the right and assign it to the variable that's on the left. So right now, toPrint, hold on, let's comment this out. Again, commenting makes it so that something isn't doing anything anymore. And if we hit print toPrint, oh, make sure we need to pause it first and then hit play. you'll notice blank is printed. Even though we have my string in here, and just to prove that it's not doing anything, you can type in hello right there. Even though we have hello and 10 set to my irrelevant integer name, we get a blank output. And that's just because what we're printing now is the toPrint string. Hold on, let's make sure we stop Unity first. There we go. And then hop back into Visual Studio. I said hop back into Visual Studio. There we go. And that's because we're just assigning it to blank right here, and this is no longer having any effect because we commented it out. Now, one thing you can do in Unity is reassign values to variables. So we just finished setting toPrint to blank, but now we can go toPrint and then set it to something else. So in this case, we will set it to my string. So this is just setting it to the string value that we entered up here. You'll notice if we hop into Unity and hit play after it finishes compiling, it prints hello, which is the value that we have in my string. Even though it's printing toPrint, it's printing the value of my string, and that's because we assigned my string to toPrint. Further, if we go toPrint equals, we can now do toPrint plus something else. Like we can do this was appended. And then again, end every line with a semicolon. Very important. Also, if you don't end a line with a semicolon and you hit save and go over into Unity, make sure Unity stops playing, you'll see there's an error here, and if you double click on the error, it will actually open up Visual Studio again and bring you right to where the error is. And just click yes on that. And it will just point you to where the error is, and then you can just, hello. There we go, back to Dvorak mode. For some reason, this is another instance of Visual Studio. It's not supposed to do that. So let's X out of this instance of Visual Studio and hop into the other one, and it will say it has been modified outside of the environment. And you'll notice that even though we saved with the semicolon right here, the semicolon isn't there anymore. And that's because we modified this file somewhere else. We modified it in a different instance of Visual Studio, and it's just telling us, hey, something's wrong here. And if we hit reload, then it will load the new version of the file, which is the one that has the semicolon there. So that's just, if that message pops up, you know what to do. So if we save now with the terminator added, and hit play, we get hello, this was appended. We can add the my irrelevant integer name to it as well, and now we have hello 10, and you'll notice that 10 is my irrelevant integer set right here, and we can further prove it by setting that to like 30. Oh, also if you set something in play mode, it reverts to its original value once you exit play mode. So make sure you set it outside of play mode, then hit play, and now we have hello 30. So we now have a very simple thing that just prints stuff to the screen, and you might think, well, that's not doing very much, you know, like, you don't feel like you made much progress, like, there's nothing that's happening in the actual game yet, but this is actually really pretty much all you need to know for creating a controllable character in Unity. That's Unity's power. So let's hop over back to Unity, go to the project view, and create another script. We'll say another C# script and say simple character. Hit enter, double click on it, open up Visual Studio, hit reload, save changes, yes. Okay. Now we will actually be making use of update. So you can see the comments here. Use this for initialization, and that's above start, and then update is called once per frame above update. Update is called every frame in the game. While the game is running, update just gets called repeatedly, one after another as fast as it can. While start is only called once at the very beginning of the game. If we want something to move around constantly, like say in response to input or something, it has to go in update so that it's called repeatedly. So we're actually going to remove start right now. Just delete it, get it out of the way. And we're going to use some comments to just put in what we want to do. So we want to be able to just move the character back and forth. So we want get input from the player, use input to move the character. And you might be really like wondering, how do we actually do this? Like, if you don't know much about components in Unity or how things work. Unity has a built-in component called a character controller. And let's create a game object, 3D object, capsule. Now we've got a capsule here that we can move around. And you'll notice it has a capsule collider component. Let's go ahead and remove that and add the character controller component. Character controller component kind of has a built-in collider, if you will. You'll notice that it has a green like circle around it like a capsule collider would. Now if we hit play, nothing of interest happens. Even though we've got a character controller on it, shouldn't we be able to like control the character? Well, we haven't actually told the character controller to do anything yet. The character controller by itself doesn't do anything. We have to tell the character controller to do stuff, and then it will take care of some of the finer points for us. So, for example, well, first of all, if you create a public character controller, this will let you drag and drop stuff in the Unity editor. So we'll call this my controller, and hit save. So this is the same as if we went like public string and then we wanted to type it in, except for instead we will be dragging and dropping a character controller, but it's named in the exact same way as just a bit of text. So hop into Unity and make sure we drag our simple character system onto here. And now we have my controller that says none, character controller. And if we drag and drop the character controller component into here, you'll notice that the color changes right here and the cursor changes. It says, hey, you can actually add this here. And if we release, then it actually says controller or capsule, the character controller is now here. So now the simple character script that we're writing knows about the character controller that's on here. And now we can actually do stuff with the character controller. So if you type in my controller and then hit dot, you can't see it with this recording, but on your end, if you type it out, you should see a huge list pop up with a bunch of different things that it can do. And you can scroll down with the arrow keys. And, well, we want to move it, so let's start to type in move, M-O-V, and we see move. The description is a more complex move function taking in absolute movement deltas. Well, that sounds kind of complicated. Thankfully, there's another one that says simple move, and it just says moves the character with speed. And if you hit enter, and then have some parentheses there. Now, if you noticed in Intellisense, it said it needed a vector 3. Well, what the heck is a vector 3? Well, let's say I had 3 float values. Also, something I didn't address earlier, float x equals, if you want to assign a value to a float, doing it like this is not really recommended. Earlier, if you recall, when we were creating strings, we surrounded it with quotes. If you're creating a float, which is just like a decimal, put an F at the end. It's just the same as if you were putting quotes around it, except for it's what you do for a float value rather than a string. You just put an F at the end of it, and that tells it, alright, even though we just have an integer right here, treat it like it's a decimal value. So if we have float x, float y equals 2, and float z equals 1, you know, this is like 3D coordinates. So we've got an x location, a y location, and a z location. And you can see up here we've got x, y, and z. If we slide in x, then the object moves back and forth. Slide in y, it moves up and down. And slide in z, it moves forward and backward, from this direction anyways. The way that Unity handles these sets of 3 numbers is a vector 3. So rather than having to create a separate float for each value, you just create a vector 3. So rather than just doing, say, float x equals 1, hold on, let's paste that there. Not vector 2, vector 3. My vector. Now, by itself, if you want to set it to something, you cannot simply just write in the numbers. You can't just say, all right, we'll have 3, 2, 1. And notice that it throws an error. And it says, cannot implicitly convert type int to vector 3. Well, that's confusing. What it basically means is this is expecting a vector 3, and the way that you create a vector 3 is by starting with a new operator, or new keyword rather, and then you'll notice in Intellisense it will automatically come up with vector 3. That's because it sees vector 3 to the left here, and then it says, well, you probably need a vector 3. So it will automatically fill in vector 3, and you hit enter. And now it seems to be working. Each one of these numbers will end up being stored in my vector in x, y, and z components. So earlier you saw we did the dot simple move. If we do my vector and hit dot x, you see that we have x, y, and z values that it contains. The x value corresponds to the 3 that we had here. Hold on, let's delete these. We don't need them anymore. And the y value corresponds to the y, the second value, and the z value corresponds to the third. Now, if we put my vector into simple move, you'll remember from the description of simple move, it takes in speed. It moves the character with speed. So we'll put in my vector. Right now we're not getting any input. We're just plugging in the vector to see how it works. And let's hit play. Oh, we have movement. And it moves off and just falls off the side. Excellent, wonderful. If we hop back into Visual Studio, so we now know that our movement works. Whatever we store in my vector and pass into here, it will make the character move. Now the problem becomes, how do we get input from the player to be stored in my vector so that we can then use it to move the player? So the way that we will handle that is by explicitly setting the x and z values of my vector dot x equals. Now what do we do here? What do we have here? We need to get input from the player. And Unity has a convenient way of doing that. In fact, if you go into Unity and hit help and then go to scripting reference, this pops up. And if there's ever something you're wondering about in Unity, you can just search it right here. So we'll go input. Let's see what it says about input. And it's like, hey, there's an input thing. Let's click on it. Alright, well there's a lot of stuff here. Well, I see a get axis returns the value of virtual axis. Well, maybe that's like a joystick axis where you can go up and down and it moves it back and forth. So let's see what that has. Let's click on that. Get axis. And they've got a nice example here. Input.getAxis, and then it has a string that says vertical. You might be wondering, well, where are these coming from? In Unity, if we go edit to project settings and then input, and then open up axes, we've got a lot of different things here. So we've got like horizontal and vertical and stuff. And if we go into scripting, hold on, if we go back to the Unity scripting reference, and we note how this is used, it's input.getAxis and then the axis name. So let's try that back in Unity here, or in Visual Studio. So we'll do input.getAxis, and then, well, it had horizontal there, and x corresponds to like side to side, so horizontal. Make sure we spelled it right. And now let's see what happens. But first, let's make sure that our vector that we set up here is just set to 0 to start out. We don't want any other odd values interfering with anything. And then right here we set myVector.x to the input. So theoretically, we should be able to move the character in x by hitting left and right if that's what the horizontal axis corresponds to. And if we hop into Unity and hit play, and hit left and right on the arrow keys, you can see we do actually get character movement, but it's absurdly slow. So we need to add like a speed parameter that we can set the character speed from. So what we'll just do public float, and if you recall, we have to put an f on the end of any value that we store. So let's just call it let's just call it speed. The name is irrelevant, but we're just calling it something that we will be able to recognize it by. Equals, we'll say 3f, just so that it knows it's a float. And then down here, we can do myVector equals myVector. Again, the same thing that we did with the string back in my first script. We're setting it to something, to itself plus something else, except for in this case we're multiplying it, times speed. So myVector equals myVector times speed. This will essentially just multiply my vector by the speed value that you set. And if we hit save and hop into Unity and hit play after it finishes compiling, see the character now moves a lot faster. And if we select the capsule and fiddle with the speed here, let's put it to like 13, see it now moves a lot faster. So we can change this in real time by just clicking and dragging on the word here to set the value. We can even give it negative speed so that when you press left it goes right, and vice versa. But we can't move it up and down yet because we haven't done anything with the z-axis. So my vector.z equals input.getAxis. And since we had horizontal before, we now do vertical. And hit save. Now hop back into Unity. And now we can move it back and forth and forward and backward. And if we walk off the edge, it just falls. If we open up the scripting reference again, and this time we type in character controller. Hit enter. The first thing that pops up, excellent. And we go down to the methods. Let's look at simple move. Where is it? You can use Control F, simple. There we go. It's under public functions. So we've got move and simple move. Let's click on simple move. Moves the character with speed. Velocity along the y-axis is ignored. Speed is in meters per second. Gravity is automatically applied. So it doesn't matter what we put into the y value in here. So I could set my vector dot y to 9001. Let's put it 9001. That seems like a good value. And hop into Unity. Ah! Window, please. Alright. There we go. I beat the window dragon. And hit play. It doesn't shoot up in the air as if our vector was telling it to go upwards, and that's just because, as the scripting reference is telling us, it's completely ignoring the velocity along the y-axis. So that also means, since it's taking care of gravity automatically, if we hop back over to the scene view and create a cube, let's say, and let's rotate it a bit, scale it around a bit, so you've got a ramp. Let's rotate it a bit less. Doesn't really matter. Move it down, hit play. We can actually walk up the ramp, walk off it, and go down. And it all works fine and dandy. Oh, one thing you'll notice is we can't control the character in the air, like they're stuck on their movement after they go airborne. And that's, I guess, an undocumented feature of simple move. It will only let you move the character if the character is grounded. Now, since it's ignoring velocity in the y vector, that means we can't really tell it to jump. Like, we can't tell it, alright, move upwards with a velocity of 10, jumping at 10 meters per second. Which means we're going to have to use the move method to do that, rather than the simple move. But with move, things get a little bit more complicated. So in the next video, we will take care of getting move into place, and we will also fix the issue of, if I select the camera and align it with the view, and hit play, you'll notice that moving the capsule isn't relative to the camera. Like if I hit up and down, it's not moving it up and down from our viewpoint. So we'll fix that as well in the next video, and until next time, thanks for watching.